Example 1, for the automobile shown on page 196, so again you have to open up your book there to see that. The ratio of the actual length to the scale drawing length is equal to the ratio of the actual width to the scale drawing width. So I do that. A lot of times I put ration instead of ratio. So looking at the car, I'm seeing the actual length. So actual length is 16 feet 6 inches. And the actual width is 6 feet. The scale width and length are on that blueprint on that page 196. So the scale length is 4 1/8 inch. And the scale width is 1 1/2 inch. Okay, so writing down all the pertinent information here. It says find the scale factor of the drawing. Okay, so scale factor is if you have picture 1 versus picture 2, big versus small, whatever. In this case we have the big car units, which is the actual length and width. And we have the small, which is the scale length and width. Okay, one thing that would be helpful for us was to get things in the proper units, so same units. So I would personally, if I were doing this, change everything to inches. Because this is 4 1/8 inches, 1 1/2 inches. It's easier to change these feet into inches than it would be to change the inches into feet. We deal with some pretty ugly fractions there. So if I got 16 feet 6 inches, and I know 12 inches equals 1 foot. Notice I'm just focusing on the 16 feet part of it because 6 inches is already inches, right? So 16 feet, if I multiply that times 12 inches over 1 foot, that gets me 16 times 12, which is 192. So 16 feet is 192 inches. And if it's 192 inches and 6 inches, 16 feet 6 inches would be 198 inches. The actual width is 6 feet, so same idea, 6 feet over 1, I'm going to multiply by 12 inches over 1 foot. So foot cancels foot, 1 on top, 1 on bottom. We're left with 6 times 12, which is 72. So the actual width is 72 inches. But again, getting everything in the same unit, if I'm going to do a scale factor, that's kind of helpful. Okay. Now, as far as scale factor is concerned, I can either go from the actual length to the scale length, or the actual width to the scale width, or the other way around. Looking at them, they're going from the scale to the actual, so we'll do it that way. So, what they're asking me for is what number do I multiply by this to make that? That's what a scale factor is. I'm trying to find this magical number that if I take this number times that, I'm going to get, well, actually, this number. So in other words, 4 1/8 inches times an unknown scale factor, and I usually put SF for scale factor, is equal to the actual length. Or I could do 1 1/2 inch times the scale factor is equal to 72 inches. I can go length to length or width to width. The scale factor is the same, because it says the same ratio is used for both. All right? All I got to do is solve these problems here. Now, again, I'm allowing you to use calculators at this point. Probably the easiest way to do this would be getting decimals. So if I made 4 1/8, if I just do 1 divided by 8 equals, that's 0.125. So 4 1/8 is 4.125 times the scale factor equals 198. And this is just basic algebra at this point. When you have something times the unknown equals something else, we divide both sides by the coefficient, which is this 4.125. So again, you create the mathematical structure and then you use a calculator to calculate. So 198 divided by 4.125 comes out to 48. I could have also done the 1 1/2 times scale factor. So 1 1/2 is 1.5. So 1.5 times the scale factor equals 72. The scale width times the scale factor equals the actual width. This should also be 48. It says it's the same. Divide both sides by 1.5. And I'm going to type in my calculator 72 divided by 1.5, and that comes out to 48. So find the scale factor of the drawing. Scale factor is multiplied by 48.